Radius. The relative size of the bent portion of a pipe. The National Electric Code in Chapter 9, Table 2 lists trade size conduit. When we say trade size, that means that these are the sizes available. Say if you go to your local electrical supply house, these will be the sizes that will be available to you to use in the field. Now, what we're going to make sure that we focus on is that, let's say this 1/2 inch trade size conduit or tubing, the minimum radius is 4 inches. There are benders that will bend pipe that would not qualify or would not meet NEC requirements because the radius is not large enough. Let's look at this 6-inch trade size conduit or tubing. The minimum radius for that conduit would be 30 inches. So basically, from here to here, if we measured, it would be a minimum of 30 inches. Now, the only time that we'll ever be actually using this method is when we have a bender. Let's say that Schaffhauser gets called to a location and they have an old bender at their plant, and you don't have access to a Greenleaf 555 and you have to use their bender, and there's no factory specs on it. The only thing that the code requires is that you meet the minimum radius bend. So that would be the first thing you would do, is say, hey, do we have on a 90-degree bend, do we have a radius that meets or exceeds the requirement of the National Electric Code? And then you would say, yeah, it does. So the second thing you would do, if there was not manufacturer specifications provided this information to you, then you'd have to go old school, and you would have to use this method in order to find out the needed measurements and the needed numbers when we're bending a conduit. So if we need to find the radius and we don't have the factory specs, we would bend a piece of conduit. We would mark the beginning, we would mark the end, and we would measure a straight line from the beginning of the bend to the end of the bend, and that would be our chord. So chord times 0.707, which is a constant, not changing, that will give us our radius. So this is the radius. Knowing the radius is the first thing that we'll need to know about the bender in order to use this method. A is the front of the shoe, and we'll talk about that. On the shoe, this is called a hook. B is the beginning of the bend, C is the center of the bend, and D is end of the bend. On this method, we have standardized what we call individual marks. So we have A, beginning of the hook, or front of the hook, excuse me. B is the beginning of the bend, C, center bend, and D is the end of the bend. Segment bending. And if you'll notice, let's back up to this type bender. In one smooth motion, we can bend 90 degrees. So that we go from zero, straight piece of pipe, 0 degrees, all the way to a 90-degree bend in one motion. One shot, it's done. Now in segment bending, each one of these marks represents a bend. All right, so as you can see, in segment bending, you bend many bends. So let's say that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we have 10 bends and we're bending a 90, so that'd be 90 degrees divided by 10. That will equal 9 degrees per bend, and that's called segment bending. You say, well, that's a lot of trouble. Yes, it is. So why would you want to do that? Well, let's say that we're in the industry and there's a small silo or a blowpipe, a storage container, and it's round. And we don't want to run our conduit like this around the, let's say this is a container. Let me draw a better drawing. We wouldn't want to bend it like this. It doesn't look good. So what we want to do is we want to gradually bend our conduit to match the circumference and the radius of the existing structure. And that is the only time that you would really be required to bend. Or something comes to mind is if it's a high voltage cable and it requires, earlier we said that the 6-inch tubing or conduit required a minimum of 30-degree radius. Well, let's say if we're doing some high voltage cable and the power company says, hey, no, we're going to do 6-inch, but we're going to require a 50-inch radius or a 60-inch radius or whatever. So you'll be forced to use segment bending. All right, what was circumference? Okay, that is the distance around the outside of the circle. In this graphic, the radius of the circle is defined as half the diameter. The distance from the center portion to the edge of the circle. All right, earlier we said, hey, let's look at an example of gain, and then when we read the textbook definition, it'll start to make sense. But let's look at, we have a 30-inch piece of conduit, and gain can, in my opinion, can be understood by looking at the formula. Stub plus leg minus length before you start. All right, so this is 12-inch stub. We have a leg 21. So we've got a 12-inch stub. We have a leg of 21 minus 30, and that's the length we started with. So in this case, we have a gain of 3 inches. "12-inch stub plus 21-inch leg minus the length when we got started. So that'd be 33 minus 30 equals 3 inches. We're gaining 3 inches by taking a shortcut, by taking Why? What's the shortcut I'm referring to? Then go straight and make a 90-degree. We had a arc, and I would like to refer to this as a shortcut. I think that's it. I tell you what,